Now we can talk about simplifying roots. And this is a very important topic on the test. You see, because often we have to take a square root in a problem, and the problem itself will result in the square root of a large number, but the square root of a large number will not appear among the answers. The answer choices will be in simplified form, so we have to recognize how to simplify a radical. So if we have something large like square root of 75, how do we simplify that and write it in a form that would appear in the answers? So that's what we're going to talk about here. As we learned in the previous lessons, roots distribute over multiplication, so we can separate a root of products into a product of roots. So if I have a product under the roots, I can separate that into the square root of the first one times the square root of the second one. First of all, remember, it is easy to find the square root of perfect squares. As a reminder, here are the square roots of the first 15 perfect squares. So square root of 49, we're asking what number do we multiply by itself to get 49, and of course the answer to that is 7. And similarly for all of these. And these are just good numbers to know. Now, as we learned in the previous lessons, roots distribute over multiplication. So as we said a moment ago, we can separate the root of a product into the product of the roots. So the root of the product, p times q, equals the product of root p times root q. And now notice, if p or q is a perfect square, then that square root would be very easy to simplify, and the entire expression would simplify. So for example, suppose at some point in a problem we needed the square root of 75. Maybe the answer to the question is the square root of 75. Well, square root of 75 is not going to appear in the answer choices, but clearly 75 is a multiple of 25, and 25 is a perfect square, so we can use that to our advantage. So I'm just going to write square root of 75. It's not going to appear in that form, but I'm going to write that as a product of 25 times 3. Now I can separate the roots, and now square root of 25, that's something I can simplify. Square root of 25 is just 5, and I can just write this whole thing as 5 root 3. So 5 root 3 is equal to the square root of 75. It is the simplified form of the square root of 75. So the form square root of 75 would never appear as a multiple choice answer on the test. It would always appear simplified as 5 root 3. And that's why it's important to know how to do this procedure of simplifying roots, because we have to make the answers into a form recognizable on the test. The way the test itself will list the answers. So here's some more to practice. Pause the video and then we'll talk about this. Okay, in each case what we're doing is we want to express the number under the radical as the product of a perfect square times something else. So 12 is divisible by a perfect square. It's divisible by 4. So I'm going to write it as 4 times 3. And then, of course, square root of 4 is just 2. So then this just simplifies to 2 root 3. 63, I can write that as 9 times 7. And square root of 9 is 3. So this becomes 3 root 7. 80, I can say that it's divisible by 4, but actually it's also divisible by, we divide it by 4, we get 20, we can divide by 4 again. In other words, 80 is actually divisible by 16. And so we actually save a bit of time if we write this as 16 times 5. And the square root of 16 is 4, so this is just 4 root 5. And then 175, well, that is 7 times 25. So 25 times 7, take a square root of that, and what we get is 5 root 7. And those are all simplified roots. And so in the test, you'd never see square root of 175 listed as an answer choice. You'd see it listed as 5 root 7, the simplified form. Suppose the number beneath the radical is particularly large. Suppose we have to find the square root of 2,800, for example. It certainly will help to factor out larger squares such as 100. It may be necessary to find the full prime factorization of the number. Here we can simplify immensely simply by factoring 100 out of the radical. So square root of 100, of course, is 10. So this just becomes 10 root 28. But 28 I can also simplify. That's 4 times 7. And the square root of 4 is 2. So it's 10 times 2 root 7, or in other words, 20 root 7. And that is, in fact, the fully simplified form of the square root of 2,800. Here's a practice problem. Pause the video and then we'll talk about this. Okay, well, first of all, we know we cannot add through the radicals, so we certainly can't add 48 plus 75 plus 192. So instead, we have to simplify each one of those radicals. So let's take them one at a time. 48 is certainly divisible by 4. It's 4 times 12, but 12 is divisible by 4 again. So this means that 48 is actually divisible by 16. So we can write it as 16 times 3. Of course, the square root of 16 is 4. So the 16 comes out of the radical as a 4, and we just get 4 root 3. 75 we've already looked at. This is 25 times 3. 25 comes out of the radical as 5. So this is just 5 root 3. Right away, very interesting. The first two are both multiples of root 3. Makes us think what maybe the third one would be a multiple of root 3. What happens if we divide 192 by 3? Well, we know that 180 is 60 times 2. 60 times 3. And so subtract 192 minus 180, that's just 12. And of course, that 3 goes into 12 4 times. So 3 goes into 192 64 times. So this is actually 64 times 3. And that we can really simplify because 64 comes out of the radical as 8. Square root of 64 is 8, so we get 8 root 3. Well, now we've simplified all three. So all three are in simplified form, so we can simply add them. So 4 of anything plus 5 of that same thing plus 8 of that same thing has to be 17 of that thing. So the whole thing just simplifies to 17 root 3, and we choose answer choice A. In summary, we simplify square roots by factoring out the largest perfect square factor. If we can find the prime factorization, or if it is given, then we can use that. Any pairs of prime factors and any even powers of primes are perfect squares. So that can be helpful too.